Hi friends, in the last video we come across with classification of conics with respect to the cutting plane angle or section plane angle. So there are 6 conics are there. They are circle, ellipse, parabola, hyperbola, rectangular hyperbola and straight line. These shapes can be obtained by sectioning a cone with respect to the semicone angle. So all these we learned in the previous session, and here we are going to know what is the eccentricity values of these conics and what is an eccentricity and what are the various terminologies we should come across in this particular element we will learn. So what is an eccentricity? Eccentricity is the ratio, means numerator and denominator will be there. It is the ratio of distances of a point. Let us consider this is a point. This particular point distances means that it is the ratio of distances of a point P from a fixed point. Means, so numerator is going to be the distance of a point P from the fixed point, that is PF, to that of a fixed straight line, So let us consider there is a fixed straight line here. So what is this distance we have to consider? So there are various distances will be there. This is one distance from P. This is the distance of point P from the line, and this is going to be the another distance. Among these, which one we have to consider? Whenever we are going to consider the distance of a point from a line, always we need to consider the perpendicular distance. Let us consider this particular point is K. Therefore, now if you observe the definition, what it is, eccentricity is the ratio of a point from a fixed point to that of a fixed straight line, So it is K. So I hope now it is clear to you. So eccentricity is the ratio of distances of a point from a fixed point to that of a fixed straight line, Therefore, it is the ratio of PF by PK. It is good. But what is a conic, sir? So, for example, let us consider in this situation, we got E value as 0.72 or some value. We got 0.72. So, PF by PK value, we got it as 0.72. Now tell me, is this value is going to satisfy by only one point, or few more points in the plane will also have the same eccentricity value? Yes, definitely. Apart from these, few more elements in this particular plane will have the same ratio. So if you join all the points which all are having same eccentricity value, these are called a conics. It is called a conics. So now I will give the definition of a conics with respect to the eccentricity. It is the locus of a point. It is the locus. What is meant by locus? Means various locations of a point. Locus is nothing but it may be a line or a curve or whatever the path it may be. It is a locus, means various locations of a point. It is a locus of a point which is moving in a plane. This is important. Which is moving in a plane. Such a way that its distance from the fixed point to the fixed straight line is always constant. its distance from a fixed point to the fixed straight line is always constant. So what is that statement? Point to line, that is nothing but eccentricity. So it is the locus of a point which is moving in a plane such a way that whose eccentricity is constant, whose E is constant. So instead of giving a lengthy statement, we wrote E as constant. So here if you observe, all these points are having same eccentricity value. All these points are having same eccentricity value. That is, in my example, I was considered as 0.72. 0.72. So here, what is meant by a conics? It is a path. It is a locus of a point P moving in a plane such a way that whose eccentricity means its distance from a fixed point to the fixed straight line is constant. Good. So this particular locus, this curve is going to be considered as conics. Good. What are the other terminology we will come across in these? So another one is the line which is perpendicular to the directrix. The line which is perpendicular to the directrix and passing through the focal. Passing through the focal is called an axis, but it is considered as principal axis. Principal axis. Okay. And what is this fixed point is termed as? Fixed point is considered as focal. So F is considered as focus point or focus. And what about fixed straight line? It will be considered as directrix. Fixed point is a focal, fixed line is a directrix. And what is principal axis? The line which is perpendicular to the directrix and passing through the fixed point or focus is considered as the principal axis. And what about the other elements? The point where it touches the conic, where it touches the principal axis is considered as V. What is V here? It is considered as vertex. It is considered as vertex. Now, vertex is a point on the conics or on the curve where it meets the axis. Where it meets the axis. Good. Apart now, vertex is also a point on the curve, and let us consider intersection of axis and directrix is O. Now V is a point on the curve. Therefore, it should also satisfy the same eccentricity condition. Therefore, E is equal to the distance of V from a fixed point, that is VF, divided by V distance from a fixed straight line, that is VO. So eccentricity, another formula is VF by VO. VF by VO. So apart from this, any other terminology we have to know? Yes, the line which will join 2 points on the curve is considered as a chord. 2 points on the curve will be considered as the chord. Am I right or not? It is considered as the chord. And the chord which is passing through the focal, is considered as focal chord. Focal chord. Good. Now one more thing is that the chord which is perpendicular to the axis, or parallel to the directrix. The chord which is perpendicular to the axis or parallel to the directrix is considered as double ordinate. It is considered as double ordinate. Double ordinate. And which is also, once if you consider as a parabola, normally we will consider like this. In this case, this is the axis and here it is the directrix. In this case, this particular double ordinate is also considered as the base. double ordinate is also considered as the base. And what about the perpendicular distance between double ordinate and the vertex axis? This one is called abscissa. So the distance between double ordinate to the vertical or length of the axis from vertex to the double ordinate is considered as abscissa. But whereas in parabola, you are already familiar, this one is height of the parabola. Abscissa and height will be used alternatively in case of parabola. Double ordinate will be considered as the base in case of parabola. Apart from this, one more element is there, that is the double ordinate passing through the focal. Double ordinate passing through the focal is called what it is? The double ordinate which is passing through the focal is considered as latus rectum. Latus rectum. So these are the terminologies we have to remember in case of conics whenever we are considering the eccentricity. So that is directrix, focal, conics, principal axis, double ordinate, abscissa, latus rectum. So these are the terminologies we have to come across. Apart from these, sir, just now you said eccentricity is the ratio of the distance of a point from a fixed point to the fixed straight line. Now the conics is the locus of a point whose E is constant. Okay, so we are having different conics. So first one is a circle, second one ellipse, third parabola, fourth one hyperbola, fifth one rectangular hyperbola, sixth one is a straight line. Good. So what are the values of these for the different conics? What is the E value for these conics? So I am going to give the values here, and later I can able to explain with show it with the video and how the various elements are going to be changes from one to other. So remember, for circle E value will be 0, for ellipse E is less than 1, for parabola E is equal to 1, hyperbola E is greater than 1. This is most important. For rectangular hyperbola, E is equal to root 2, that is equal to 1.414, and for straight line E is equal to infinity. E is equal to infinity. These are the values you have to remember. Among these, so these three terms majority of the people are aware of it, but most of the times either it is in the interviews or in the competitive examination, you may get the question from these three, that is what is the eccentricity value of a circle, rectangular hyperbola and a straight line. So you gave this, but how we can able to say this is correct, sir? So with the help of some diagram I can able to explain to you. First of all, let us consider for circle. How it is going to be, sir? Let us consider this is the circle. Here what will happen? Here the directrix are present at infinite distance. Directrix are at infinite distance, and let us consider this is the point P, sir. And here focal points, here remember always it is a 2, it is not 1. So here F1, F2, these two are coincide with each other, and we are going to consider this is the axis. This is the axis. Now here if you observe, this particular point is O1, this is O2 or 02, and it is V1, V2. So once if you consider eccentricity E is equal to Vf1 divided by VO1. Now VF, or otherwise we can able to consider PF1 by PK1, but both are almost same. Now if you observe, PF1 is having certain value, it is having certain value, but the denominator is infinity. Once the denominator is infinity, automatically this particular E value is 0. E value is 0. That is why eccentricity value of a circle is 0. This is one way of explanation. Another way also there to get eccentricity as 0, that I will give in the next video. Next one is for ellipse. In case of ellipse, what it is happening? So in case of ellipse, the directrix are coming closer. They are coming closer. And focal points will be separated. They are not coincide now. They are going to be deviated. They are moving away from each other. Then if you consider the locus of a point which will maintain the same eccentricity value, we are going to get it an ellipse. We are going to get it an ellipse like this. So here these two are coming closer, directrix are coming closer, focal points are moving away from it. So whenever this ratio is equal to 1, whenever the ratio is equal to 1, they will be interchanged whenever E is equal to 1. So what will happen? Focal points will be further moved away, F1, F2. But the directrix will comes inside these two focal points. Inside to these two focal points. And the curve we are going to get like this. But for parabola we will draw only one side. So this is V. This is O1. So VF2 divided by VO1 is same. These two lengths are same here also. This particular length and these two will be same. One second. Here focal is not this much length. And here it is going to be the same distance from it. So this length and this length both are going to be the same. So we are going to get it as a parabola. And I am going to give one question to you. Why it is called parabola? And another one is why the next one, if E is greater than 1, it is considered as hyperbola. It is considered as hyperbola. Why it is called hyperbola? These two questions you try to give the answers in the comment section. I will give the answer to you, or otherwise in the next videos I will give that information. So whenever they are going to come further closer, these directrix are coming further closer, and focal points can able to move away from each other, further away from each other. Now the curve we are going to get it as like this. The curve we are going to get like this. This is considered as hyperbola. Whenever it is a hyperbola, we will come across with one more term. What it is? That is called asymptotes. That is called asymptote. So what is an asymptote? So remember, I am going to write that information. Asymptotes. What is an asymptote? So it is the tangent to the curve at infinite point. These are the tangents to the drawn to the curve at infinity. So asymptotes. What is the asymptotes? Asymptotes are the tangents to the curve at infinite point. Because hyperbola is a open curve, it is having infinite point. It can able to expand up to infinity. That is why the asymptotes are the tangents to the curve at infinite point. Sir, what is the nature of these asymptotes? So asymptotes will be either less than 90 degrees. So once the hyperbola is like this, once the hyperbola is like this, it is goes on like this. This is an hyperbola. Asymptote's angle is less than 90 degrees. Sometimes asymptotes angle will be more than 90 degrees. In this case, hyperbola is going to be like this. But in one particular situation, whenever it is transferring from acute angle to the obtuse angle at one particular stage, when theta is equal to 90 degrees, so asymptotes angle theta, asymptotes angle is reaches to 90 degrees, then it is called rectangular hyperbola. Rectangular hyperbola. So why it considered as a rectangular? Because of angle between asymptotes is 90 degrees. That is why it is considered as rectangular hyperbola. And one more question you will get it, sir, how we can able to get E is equal to root 2? This one also I will explain in my next video. So I said two words. What all are they? One is how I E value is 0 for the circle. How you can able to give say that E is equal to root 2 for rectangular hyperbola. For circle, why it is 0? For rectangular hyperbola, why it is 1.414? These two I will explain in my next video. In my next video. Apart from that, why when E is equal to 1, why it is considered as a hyperbola, and why if E is greater than 1, why the curve is considered as a hyperbola. These two things we will consider in my next session, next video. When E is equal to 1, why it is called parabola. When E is greater than 1, why it is called hyperbola. These two also I will explain in my next video. Now, sir, what happened to the next case? Sir, if directrix are coming further closer and they are going to be coincide with each other. So this is the directrix 1 and 2, they are coincide with each other. But focal points are moved to infinite distance. So here it is F1, this is F2. These two are at infinite distance. Then what will happen to the curve? The curve will be coincide with the directrix. The curve, for your clarity, I am drawing little bit beside, but these two are coincide. Now if you observe, the point V is on the curve. This is V, sir. This point is going to be V. V1 comma V2. Same point is related to O1 comma O2. Now we know eccentricity E is equal to V1 O1 divided by V1 F1. So V1 O1 it is 0. Denominator is infinity. Therefore one second. Sorry, I wrote it as a reverse. So it is going to be V1 F1 divided by V1 O1. So V1 F1, the distance between V2 F is infinity and divided by very small value or nearer to 0. Very small, either you consider as 0.0000 some way. So it is almost 0. Then also it is going to be infinity. So that is why for straight line, focal points are at infinite distance. Directrix will be coincide with the curve. Whereas if it is a circle, focal points are coincide, directrix are at infinity, and then we are going to get it as a circle. So for this, I am going to show some particular GIF file that can able to give a little bit more clarity to you. All of you carefully observe this video to get the clarity. So I will play this video twice or thrice for your clarity also. So now here in this video, if you observe here, you can able to observe it is a circle. And here 2 points, if you observe here and here, they are moving away. So previously they are coincide. Now you observe, you are observing only 1 point, and here it is showing it as 0. Here it is showing it as 0. Are you observing, my dear friends? Wherever my cursor is placed, here it is E is 0. Here it is going to be a single. Now whenever E is increasing, E is 1.0147. So here if you observe, 2 points are observing on the x-axis. These two are focal. So up to now the directrix are very far. Whenever E value goes on increasing, observe that points are moving away. So this is moved further away. Now again further moved away. Now you observe two more lines comes into this video. That is these two lines, this line and this line. These two lines are called directrix. Now if I am going to move increase further E value, here if you observe E value goes on increasing. So if you are going to subscribe this, if you send your link, I can able to send this GIF files to you, my dear friends. Now here if E value goes on increasing, directrix are coming closer, focal points are moving away. Carefully observe in this video. So whenever E reaches to 1, if it is 0.833 here, now directrix are coming very close, focal points are coming nearer to vertices. So whenever E crosses 1, just you observe, E crosses just now 1.014. The directrix will comes inside the focal. Focal will move away. Directrix will be shifted inside to the focal. Now we are going to get parabola as well as hyperbola. So observe, directrix are coming closer. Once the directrix are coming closer, the curve is going to be widening. So finally, whenever E value goes on increasing, the curve is going to be flattened. The focal points are moving further away from each other, and at one stage the curve and directrix will be coincide with each other. They will become very close and it will be coincide. I hope now you understood. So if you observe this video twice or thrice, you can able to get the idea of this particular, how E value is changing, how the directrix are going to be changes according to the relative positions of directrix and focal points. I hope this one is clear to you. In the next video, we are going to concentrate on some more concepts of conics. Apart from that, the few questions which I thrown in this video also we are going to discuss. Thank you, my dear friends. All of you try to like the session and subscribe this particular channel to get a regular updates of my videos.